Okay, Patty, I propose we get started.
Perfect. So good afternoon, everyone, and welcome to the F5 workshop. Today we will cover how to publish your APIs with confidence. My name is Patty Lewis, and I am the commercial lead at F5 for Luxembourg, and I will be your facilitator for today's session. Before we get started, just a few housekeeping items to note. If you have any questions throughout the presentation, please submit them in the chat box at the end of your screen, or you can drop me an email. I've left my email address there. We will have a Q&A session at the end of the presentation. Also, in F5's virtual booth, you will be able to download more detailed information around this topic, like our API management solution, application protection solution guide, and so on. Or please book a meeting with us. We're more than happy to have a more granular discussion with you throughout the event. Today's workshop is led by Koen Vanderpoorten. He is a senior solution engineer at F5. So without much further ado, Koen, over to you.
Thank you, Patty. Okay, thanks for being here. So in the coming half hour, I will be talking about what is our strategy towards you or enterprises in general, managing and protecting their APIs. So if you have attended any of the workshops lately, you will certainly have heard that we are in the midst of a digital transformation, and we believe that APIs are a very important part of that digital transformation. Just to recap, what is digital transformation? Well, it's based on applications, of course. It is very important that user experience is very good with the companies or an enterprise's applications, because they are the outward facing, let's say, face of the company. The business agility is also very important. Businesses want to evolve very fast, and IT needs to follow, of course. And we have now come to a point where, we speak of digital ROI. That means that the things that IT does, that it needs to make money, and the application that they publish, it needs to make money. So how did we get here? It's probably worthwhile to look back on a bit of history in order to appreciate where we are today. You know that economy for thousands of years was based on population growth and trade among people over short or longer distances. But we all know that in the 1800s or the beginning of the 1800s, something came along called the Industrial Revolution. And that basically changed everything. From that moment on, the value of a company or an enterprise or a business was measured based on their physical capital. So in other words, the more factories, the more machines that a business had, the richer they were. Good examples are Ford or Carnegie or Rockefeller or the enterprises in Europe as we know them now. About 100 years later, beginning of 1900, this started to change because we went to a services economy, an economy driven by services and by people. So at that moment, enterprises or businesses were valued based on their human capital. Good examples are IBM or McKinsey and Company. And the smarter the people are in your business, the more value you have and the more value you can deliver to your customers. And then this is where we are now, where companies are often valued based on their applications. Very good examples of that are Waze or Facebook, which are basically an application. There's nothing else but the application. So it represents their capital very well. And if their application is not good, They will not make any money, of course. But it's even shifting towards the more, let's say, traditional industry, like Nike, the shoe salesman. They can make a difference by having a good digital, by offering a good digital experience to their potential customers. So where does this change leave corporate IT? Well, it is a fact that if corporate IT works together with the business in this new economy, in this application economy, that's where customers see the value, and those companies will thrive and they will make money. Now, of course, it involves quite a few changes for corporate IT. They need to embrace and enable chaotic innovation. It's the business agility that they need to follow. Business today or tomorrow, they think about something new. They want to open a new direction, and IT just has to follow. And combined with that is, of course, the responsibility of corporate IT for keeping everything secure. Okay, so, and that's a challenge, and that is one of the reasons why companies, for example, are adopting agile IT or DevOps, because it enables them to go to walk that chaotic path while still being secure. So this all leads us to APIs, and APIs are for us the gateway to digital transformation. There is a lot to do about APIs nowadays. If you see this graph, for example, I took it from the website of Programmable Web, which is basically like the journal of APIs, quite an interesting website. APIs haven't been around for very long. So more or less since 2005, I believe Salesforce was the first one to publish an API. And it started slowly, but now you can see a very fast growth, and it's only going faster and faster. If you look on the website of Postman, for example, Postman is an API testing tool. Well, they report that every year the download of their software grows by 100%. So that should be equivalent to how fast the deployment of APIs is growing right now. Now, what are the reasons for using APIs? Well, there's quite some, of course. It has to do with technical reasons, but also, of course, with economy or money. APIs allow companies to sell services and amplify their businesses. And basically, we can break it down in 4 classes. Companies can offer their API for free, like, for example, Facebook. And that way they can make money because it allows them to get more popular. It allows them to get more adopted among users. And in turn, they can then use publicity, for example, or advertising on Facebook to make money. Another example is where the developer pays. A good example there is PayPal. They offer their services for developers to use. What are the advantages for a developer? Well, he does not have to implement a complete paying system on his website. He does not have to invent that code. He simply points to PayPal, and for every transaction that's being made, PayPal will take a tiny percentage of that, or a small percentage of that, and that way they can make money. It can also go in the other way. For example, Expedia is a search engine for airline flights, and those guys, they pay the developers. Every time a developer points from a website to Expedia, and somebody follows that link, goes to Expedia from the developer, they in turn will pay Expedia a small fee. Okay, so that goes the other way. And then, of course, there's also indirect money making. eBay would be an example for a good example. If I had a web shop or a shop on eBay, I could use their API to mass post new items on eBay. And by selling those items, eBay can make money, okay? Now, of course, there are also technology reasons for adopting APIs. What you see here is a traditional app, and traditionally we speak about a client-server infrastructure. So that means a weak or a client with relatively weak CPU power. On the other hand, a server with a very big CPU and lots of memory that can do the heavy lifting, okay? Well, that has changed, okay? What we're talking about right now are, for example, a smartphone, which is a very powerful tool. And so it can do all the heavy lifting itself instead of having to rely on a server. So it can run all kinds of scripts and rendering in the app or in the browser itself, and then just post the results to the server. So the server is not the processing unit anymore. That job is being done by the client, and the server is just, let's say, a proxy for a backend where the data is residing, where you can do Elasticsearch, etc. Okay, and what we see is, instead of exchanging HTML pages, we are now exchanging JSON packages or JSON blobs. And that's another advantage of APIs, of course, because developers only need to know one language, which is JSON, and they don't have to support all kinds of stuff like Flash and all those other things anymore. Another thing is the evolving applications themselves. We come from a time of monolithic applications, where an application is one big block of code, of millions of lines of code. If you want to address that code via an API, there is one way in. At this moment, that big block of code that was very unwieldy to handle or to maintain or to upgrade has been broken down in separate small parts. We call them microservices, and each microservices is performing one small part of the tasks of the whole application. Okay, you have a web UI microservice, billing microservice, a shopping cart microservice, for example, and all these tiny applications which are containerized work together. Okay, and the way they work together is through API calls. So you can already see that APIs are everywhere now. If modern applications are developed, REST API or APIs in general are always in the loop. And of course, there are also external factors. With PSD2 upon us, yeah, there's been quite some evolution or innovation in the banking sector. So at this moment, one of the rules is that a financial institution needs to be able to expose the account and personal information of a customer towards third parties. Yeah. That's been around for a long time, but it was really more fragmented. The APIs did exist, but they were built case by case for a certain third party. Right now, we are more in the age of the public API instead of the private API. That means that a bank will publish an API on the internet for everybody to access. But of course, they need to have in place the correct measures when it comes to authorization, authentication, and security, of course. Okay, so it's basically a regulatory request having APIs now. So of course that that helps with the spread of APIs as well. Now we all know with great popularity also come a couple of risks. Hackers have not failed to notice that APIs are everywhere. And a thing is that they are often overlooked by the security teams of an enterprise. Security teams still focus on websites, on network security, but APIs are overlooked because often they are managed by other teams, by teams that the security guys just don't talk, they don't talk with them. So Gartner predicts that by 2022, that this will be the primary attack vector for data breaches. So it's really a serious risk. If you have the same concern, you're not alone, because one of the main concerns when deploying APIs with customers is, apart from lack of skills, of course, is the security concerns. How can I secure that API, that it's still accessible to the right people, but that it's safe from any kinds of attacks? Now, just to drive home the point that it is quite easy to attack an unprotected API, and that it can lead to massive consequences. I have here a use case, or a real life case, where Uber, the company Uber, was hacked by a security consultant. So that guy got a bounty and got $6,000 from Uber, because he was able to find a serious hole in their security protection for their APIs. Now, how did he do it? I'm not going to go too technical, but it's interesting nonetheless. So Uber had an API that was accessible all over the internet. And by doing some reconnaissance, that consultant was able to craft a packet that he sent to the API, and basically the only thing that was in the packet was the phone number of a driver. How did he get that phone number? By looking it up, by asking the driver. There's all kinds of methods there. Okay, so it did not do anything but generate an error message. So the API call was not successful, but the Uber API leaked something that was not supposed to happen. The UUID, or the user ID of the driver, where the phone number belonged to. And by using that user ID in a subsequent packet, and by identifying himself as that user, all of a sudden, this consultant received a lot of information from this user, or about this user, the names, the email addresses, phone number, credit card info, and worst of all, a token. And the token is basically the password that this driver could use to log into that API. So from here, the consultant was able to book rides for the customer, to see who had driven with him, etc., etc. So it's, as you can see, this is a gaping security hole, and you would not want to experience something like this, of course. Now, since this happened a week later, the security hole was patched by Uber, luckily, so we can all drive with ease. So from this previous example, you can see that this can lead, or could lead, to revenue loss, but not only that, also reputational damage, of course. Is this would be disclosed, your customers would leave you, or would leave your website in droves, of course. There are also legal, or there can be legal consequences. And now with PSD2 and GDPR, if you fail to meet regulations, you could have a huge penalty there. So it's no longer only about reputation and money, it's also a legal issue. To drive home the point with regards to popularity of APIs and API attacks, I guess you've all heard about OWASP. It's an institution that each year publishes a top 10 of the most popular web attacks, and they call it the OWASP top 10. And since last year, they also published an API OWASP top 10 with the most seen attacks or problems, security problems in APIs. Now, a lot of those are similar with what we see in web applications. And why is that? Basically because an API is just a special type of web application. We can sort them in different classes. You have problems that deal with authentication or authorization, broken authentication, we call it. We have problems that deal with access control, where somebody has too much access to your API, given his identity. There are problems that relate to application security, typically like a web server and SQL injection or cross-site scripting. And then there is also the lack of visibility in the end. Not knowing what happens on your API, you cannot defend yourself against attacks, of course. And so that brings us to our own message, the 3 pillars of OWASP API security, as we at F5 see them, which is first of all, application security. Make sure that your API is safe. Access control, know who is connecting. And third of all, visibility and administration. Make sure that you have a good overview, good monitoring, and that it's easy to administer. And for all those 3 points, we have solutions. And we have, you know, F5, we have a very good WAF. Since the acquisition of Nginx, we now also have a very good API gateway that can give you this access control. And we also have an API management system or portal that makes it easy to manage your APIs and to still have a good overview and insight. So this is the architecture as we propose it. It's a 2-tier architecture. On the front, we have our advanced WAF. On the outside, of course, you have a multitude of clients. You have APIs, you have mobile applications, but you also have attackers, of course. Well, the first line of defense, the first tier, let's say it like that, is our advanced WAF, where we have specialized security for APIs. And I will go into a little more detail later on. The second tier is the API gateway. And basically that's an Nginx product, but the two work together perfectly for you to secure and manage your APIs. We've gone to great lengths to make sure that they are also programmable. That means that they can work very well in a DevOps pipeline, that you can automate everything and in that way make it as easy as possible to deploy configurations on the 2 tiers. For F5, we use cloud intelligence, which can make the solution even more resilient. And of course, we give you good visibility and easy management of those 2 solutions. So if we go in a little bit more detail, for the first pillar, application security, I'm not going to go in a lot of details, but here's a screenshot of our advanced WAF on the big IP. We have specialized security for APIs. It's, for example, very easy to import a Swagger file. A Swagger file is a blueprint of the API that the developer can give to the security guys. Security guy imports it into the big IP and he has a complete overview of what the API is all about and the methods that are permitted, the packets that may go to the API. So that's one thing that you can immediately enforce on the big IP. We can also import JSON schemas, so the big IP knows what the JSON packets need to look like. And if they deviate from it, the big IP can block them. Okay, so you are immediately completely sure that the API is safe. Now, the second pillar is access control. Who is connecting to my API and what rights do they have? You can use API keys for that. An API key is basically, let's say, a password, but you know, a password, if it's not changed and it leaks, then there is no more, it's open for everybody, of course. So we also support federation. So you could, for example, leverage Azure Active Directory or Okta. And if somebody wants to connect to the API, he first needs to authenticate on Azure Active Directory, for example. If authentication is correct, he will receive a token, and that token can then be presented to the API gateway. And based on that token, we will also know who is connecting. If it's an administrator, for example, he has full access. If it's a user from company X, they only have access to data for company X. You can combine that with the F5 in front of it for even stronger security, and that way we can also leverage older backend applications that do not support those tokens, but that support Kerberos, for example, or older authentication protocols. And just to round this off, what is so specific about an API manager? Because you could say, in the end, it's just a load balancer or a reverse proxy. Well, yes, it is, but it is also a lot more than that. An API manager will allow you to maintain different versions of your API, version 1, version 2. It will help you publish a developer portal. You can import Swagger files automatically. It will help you with rate limiting. In the future, on Nginx, even monetization of your API, of your APIs. It's fully automatable and it has its own REST API, so you can just send a packet to it in order to configure it. You don't need to touch the GUI. And then the last pillar is visibility and administration. And of course, very important are dashboards to get a good overview. Here's a nice dashboard from the Big IP where you can see security incidents that happened on your API. And this is some of the dashboards that you can create on the Nginx API manager. So every team or every application manager can have their own API dashboard so that they can perfectly see if something is, what is happening on their API, if something is going wrong, etc., etc. Finally, as has been the case with F5 for so long, we are open to any type of cloud or orchestration system. So it's easy for us to run on Google Cloud Platform, on Azure, on AWS Cloud, but also in Kubernetes, for example. Same goes for Nginx, of course, and we work flawlessly with tools like Ansible, like Jenkins, GitHub, etc. So it's easy to automate in a nutshell. To round this off, a couple of use cases, just to illustrate that we can serve in different verticals as well. So for example, for financial services, we had a customer that had problems with random credential stuffing attacks. So these are credentials or brute force, kind of brute force attacks. But since it was financial, they could not use JavaScript. Well, by leveraging a couple of security mechanisms on top of each other, they managed to get at 100% mitigation of those attacks. Another one would be a voice provider who suffered from bots that sent them specifically crafted JSON packets, which basically DDoSed their API, well, by using rate limiting in combination with very specific profiling of those bots, they could mitigate that one. And then finally, even in utilities, it can have a place because smart meters, for example, if they connect to a backend, well, it's basically also an API connection. The specific thing there was the smart meters used WebSockets, which is an advanced type of HTTP, but we still were able to secure them and make sure that they did not suffer from OWASP top 10 attacks anymore. And that's it. So that's all I had with regards to slideware. I'm a little bit over time. I'm not sure if there are any questions, Patty.
Yes, so there was a question on visibility and management of APIs. You did touch on inventory, the versioning of the APIs and dashboards, but maybe you can enhance a little bit more on the API management side.
Okay, so let me go back to this this one. Yeah. So the API management side. What really happens is we have with Nginx, it's a two-tier model. Nginx, you have a data plane. Those are the Nginx Plus instances, and on top of that, you have the Nginx controller, which is basically like a central manager for Nginx instances. Now, one specific license that you can add is APIM or API management, and that allows you to, for example, start importing Swagger files, and then from there, define rights for clients connecting to that API with regards to what they can do. For example, if you are customer X, you connect to the API, we will authenticate and authorize you just to go to a specific server, for example. And so it's like reverse proxying, it's like load balancing, but very specifically for APIs. The way it's being licensed, and that's a nice point, I believe, it's based on succeeded responses. So if you do an API request that does not succeed, Nginx will not charge you for that. And that's a big difference with competitors. Another thing is another difference with competitors is that they are often cloud-based. For example, the Google variety. So that means that the data potentially needs to leave the network and then come back, whereas Nginx is on site, so you don't have that problem with round trip. Another thing is you can containerize everything. So it's very fast, it's very flexible, it fits perfectly in a modern application infrastructure. And of course, you have the dashboarding, you have the rate limiting, you have DevOps support, meaning that you can automate everything. Okay, I hope that helps, but I would be very happy to extend on that. Anything else?
Perfect. So I have a last one, Koen. Why if F5 propose a two-tier design for publishing APIs?
Yeah, that's a good one. Sounds maybe a little bit complex. Well, the reality is we as F5, we have purchased Nginx last year in order to be closer to the application. Traditionally, F5 is a networking and security vendor, and we don't get to talk very often with application people. Well, by buying Nginx, now we can talk with app developers, with people who are in charge of APIs, for example. And the thing is, F5 is still is and will remain a very good security player, but it's a big block of code, so it does not fit really well in a flexible environment of a modern application, and that's where Nginx fits. So we see those two solutions as being compliant to one another: a strong front door and then a lean backend that can distribute the traffic over your APIs. I hope that helps. Yeah.
Thank you, Koen. So that is the end of the questions we got today. So this brings us to the end of the workshop. I want to thank you all for joining, and thank you, Koen, for walking us through this interesting content. Just a reminder, please visit our virtual booth. book meetings with us. We're more than happy to walk through more detailed information, use cases, content. So thanks for joining. Enjoy Internet Days 2020 program, the rest of the event, and keep safe. Thank you.
Thank you. Bye.